All right, let's talk about that amazing feeling. You've done it. You've built a machine learning model. The metrics look fantastic on your laptop, and you're thinking, this is it. But then comes the big question. How do you get this brilliant piece of code out of your notebook and into the real world? Where it has to serve actual users reliably without breaking a sweat. Well, that's exactly what we're going to dive into using the powerhouse tools inside Amazon SageMaker. And honestly, this is where the real work begins. It's one thing for a model to perform perfectly in the clean, controlled lab of your own machine. It's a completely different beast to get it to thrive out in the wild. We're talking messy data, unpredictable user traffic, and performance that has to be rock solid 24/7. So that's our goal today. We're going to run the production gauntlet. We'll tackle the three big hurdles every single model has to clear on its way from a promising idea to a production powerhouse. And we'll see exactly how SageMaker gives us this incredible integrated toolkit to handle each and every one of them.
First up, the search for perfection. See, your model might be pretty good right out of the box, but we don't want good, we want great. And that means finding the absolute perfect recipe of settings, the hyperparameters, that unlocks its peak performance.
Now, the old way of doing this, it was a nightmare. Just endless trial and error. You'd spend hours, maybe even days, just tweaking settings, rerunning your training, and basically just guessing, hoping you'd get lucky. Automated tuning, though, it completely changes the game. It's like hiring a super intelligent robot to systematically test every possible combination for you. What's so amazing about this is you're essentially unleashing an army of mini data scientists to do the work for you. Instead of you babysitting one experiment, SageMaker can spin up hundreds, even thousands of them all at once. Each one is testing a slightly different recipe, all competing to find that one golden combination. And getting it started is beautifully simple. First, you just define the playground. You tell SageMaker the range of settings to explore. Next, you give it the goal. What's the one thing we care about most? Is it accuracy? Something else? Then you just press go. SageMaker launches this whole fleet of training jobs, and in the end, it just comes back and tells you, here's the winner. It's that easy. Okay, so our model is now tuned to perfection. It's the best it can be. Time to release it into the wild, right? Well, hold on. Is it ready for the chaos of real-world traffic? This brings us to our second huge challenge, scaling. Because traffic is never a nice, steady stream. It's full of peaks and valleys. Just look at this chart. Traffic's pretty calm at 8 a.m., but then bam, at 1 p.m. there's a huge spike. Maybe everyone's using your app during their lunch break. Then it calms right back down. Here's the problem. If you pay for enough servers to handle that 1 p.m. peak, you're just burning cash all night. But if you don't, your app crashes when you need it most. This is where auto-scaling comes in and saves the day. And it's brilliant because it does two things perfectly. It protects your users by automatically adding more power during those traffic spikes. But just as importantly, it protects your wallet by scaling back down when things are quiet. You get performance when you need it, and you save money when you don't. And SageMaker gives you a couple of ways to do this. Target tracking is kind of like setting the cruise control on your car. You just pick a metric, like keep CPU usage around 70%, and SageMaker handles the gas and the brakes to keep you right there. It's the simple set it and forget it option that AWS usually recommends. Step scaling, on the other hand, is more like driving stick shift. It gives you way more control to say, if traffic goes up a little, add 1 server. If it explodes, add 5. Of course, you need some guardrails. You can set a minimum and maximum number of servers, which is like setting a floor and a ceiling for your spending. And the cooldown period is also super important. It basically tells the system, hey, after you make a change, just take a breath for a minute before you do anything else. This stops it from freaking out and scaling up and down too quickly. So now our model is a lean, mean scaling machine. It's perfectly tuned, it can handle traffic like a champ, but there's this one silent killer that can ruin everything, and that is feature inconsistency. Think of it like this. When you trained your model, maybe you used a feature like average purchase amount over the last 30 days. But when a new purchase happens in real time, are you calculating that feature in the exact same way? The slightest little difference in the logic or the data, and suddenly your model's predictions go haywire. This is a massive problem called training serving skew, and it's a classic reason why models fail in production. SageMaker's answer to this is the feature store. It's basically the ultimate weapon against this kind of skew. Imagine it's a central, organized kitchen pantry for all your data features. It guarantees that the ingredients your model uses for a live prediction are the exact same ingredients it was trained on. No more guesswork.
So let's just quickly break down the lingo. A feature is just an input, right? Like the transaction amount. A record is simply all the features for one single event, all bundled together. That bundle gets a unique name, the record identifier. And, crucially, it gets a timestamp, the event time, so you know exactly when it happened.
This table really makes it click. Each row is one unique transaction, like TX-1001. And for that single moment in time, you see all the features perfectly lined up. The amount, the IP address, how old the account is. This becomes your single source of truth for everything.
And the really clever part is its dual design. You have the online store, which is built for pure speed. It only keeps the very latest feature values so you can grab them in milliseconds for a real-time prediction. Then you have the offline store, which is like your complete historical archive. It has every version of every feature, which is an absolute goldmine for training your next generation of models.
So we've covered tuning, scaling, and managing features. But the real power here isn't in any one of these tools. It's how they all click together to form this complete, automated MLOps toolkit that just solves the whole production puzzle for you. Think about what you get when you combine them. You have a system that automatically finds its own best version, a system that can handle the wild swings of real-world traffic without you lifting a finger, and a system that makes trustworthy predictions because it's always using the right data. It's the complete package. And that's really the big idea here. Using these tools is the difference between building a fragile house of cards and building a skyscraper. One is a cool prototype that only works when everything is perfect. The other is a professional, robust system that's engineered to last and built to scale.
Which leaves us with one final thought to chew on. As these incredible automation tools take over more and more of the MLOps lifecycle, the tuning, the scaling, the data plumbing, what does that mean for the job of an ML engineer? Maybe the next great challenge isn't just about building the models, but about building the systems that build and govern the models. Something to think about.